Hi. Hi, it's me again, Margaret. Uh, I am in my basement now. It is 25 degrees outside, so it's cold, and my beard is gone, even though it was just there, maybe in some of the videos. I don't know what order these are actually going to go in, so I may not have a beard until the end or something, or in a separate video. But I did record some previously where I had facial hair, and I looked my age, unfortunately. Um, I'm going to go over mode 2 of operation a little bit. I'm going to go over it again at the dyno, where we can actually do runs and see how everything works out. I just wanted to make sure I got some basics down away from the actual machine itself, where it's quieter, and not only where it's quieter, but where you'll actually be able to hear me talking because there's a microphone. And I'm not sure how well, this is a pretty good PC. I'm not sure how super well this PC is going to hold up to running screen recording software and a microphone and a dyno and a GoPro all at the same time. So I wanted to get something down just so you guys can kind of hear it. Before I queue up quantum, PC requirements are a thing some people do. Let's just go to settings on this PC. Dynocom has their own rules and requirements that they give you guys. For me, about the easiest way to run one of these dynos, buy a tough book, that's what this is, and just max it out. So here we have the RAM on this one is got 16 gigs of RAM. I would go no lower than the Core i5 200 gigahertz processor. Windows 10, Windows 11, either one of those would be fine. This one's got 10 Pro, which is a bonus because I can disable driver signature once and not really have to think about it anymore, which is something when you do install your software before you use it for the first time, you're going to want to Google disable driver signature enforcement and just follow those steps and do that, and press number 7, and then you should be good to go so far as your drivers actually showing up. Do that before you install the software is about the best way to do it. Then when you install the drivers and everything, it'll be a lot easier. You won't have communication issues with the dyno. We can close that now. Moving right along, I'm going to queue up quantum. Mode 2 of operation, when you're using the dyno in mode 2, you're no longer using the handheld to do like your steady state stuff and build fuel tables. You're actually, okay, now I want to graph power. I want to see what the car's actually doing and use the damn machine for what I bought it for. So this is what you do. The first time you open up the software, you can jump up here to the top corner, see what version of the software you have. Pretty much everything I have is on 2.9. I think we might be on 3.1 right now, or 3.2. I'm just a little bit behind because I'm a little bit lazy. But everything 2.8 and above is pretty darn stable. So if you have any of those versions, you don't really have anything to worry about. There's no major updates between like 2.9 and 3.1 and 3.2. So nothing really to worry about there. License settings. This is everything that's on your USB key. I say this in another video, just in case you need information about what the actual dyno is and what's going on with it. My inertia on my dyno is 106 kilogram meter squared because Paul loves me more than he loves everybody else. So I get a really heavy roller. Thank you. Yeah, moving on from that, the first time you open the software, when you're going to run a car, you're going to have to create a session first. So that's literally the only option you really get is to create a session. So in the beginning, you're going to click Create Session. I am just going to title this one Mode 2 Demo because we're not actually going to run any cars in my basement. I do have my DC controller hooked up so we can actually go through the process. I'm just going to pick a customer car from here. There we go. When you guys fill this part out, so when you put the VIN ID, I never put an actual customer's VIN number in there. I just put something screwy or their name or something like that. When you choose your year, make, and model, and the weight of the vehicle, do not type it in. Use the drop down menus, use these actual drop down menus here, and pick your year. There is an EPA database in the software, and if you use the drop down menu, that will be what you use to populate the VRS settings. So, like the coefficients of friction, frontal areas, power at 50, all that fun stuff. If you type it in, it's going to overwrite the database, and then the year 2010 is gone all of a sudden, or the make of Chevrolet is gone all of a sudden. So you want to make sure you use the drop down menus. Very important. Use the drop down menus for that so you don't screw that up. After you've entered all that in, we're going to hit next under owner. Put myself, baller. That's not me. That's actually my landlord. Landlord's baller. And then now we have a graph with nothing on it. Once the graph's set up, you're going to want to do some sort of power pull. There's three main test types. The main test types we use. So when you go to new run, there are three main test types. There's a lot of test types, but there's three main ones that you're going to use for power measurement. The gear roll-on is going to look most familiar to guys that are used to dynos with initials like DJ or DC. That would be the main test type I would use for most of these. Chassis dynos particularly use a roll-on test very well. I like using a roll-on hub dynos because it's extremely stable, but you do have to define your load. You have to have a little bit of experience with the dyno. You're not just going to jump in on a roll-on test on a hub dyno and just go, unless you want to get really frustrated. So gear roll-on test, that will be number 1. Number 2 is going to be virtual road simulation, the VRS test. I'll refer to it henceforth as VRS because I don't like saying all that. VRS test is using vehicles' coefficients of friction, frontal area. There is an EPA test with a coefficient A, B, and C, or for some older vehicles, a power at 50 test. So all we're doing is we're simulating the way the vehicle accelerates going down the road with these tests. So the duration of your pull, let's say we're in our 1-to-1 gear on the dyno and we do a pull with the VRS, it's going to be most similar to the way it goes down the road using a VRS test. So guys that are looking for a little more real world conditions, stuff like that, that's going to be the test for you. The other test type is the ramp test. Hub dyno guys are going to love the ramp test, and Australians love ramp tests because that's all they do, all of them. Ramp test, you're going to set a duration. So you're going to say, you can set a duration in time, like I want the test to take this amount of time. You can set a acceleration rate, like I want the vehicle to accelerate 12 miles per hour per second. I want the vehicle to accelerate 750 RPMs a second. Whatever your duration is, the dyno is going to run a PID loop and adjust the load accordingly to make sure that you get the duration you're asking for the pull. Even as power comes up, the dyno is going to come up with it. So what you end up with is a very steady test, a very steady accel rate, or a ramp. It's Mountain Dew. It's not Mountain Dew. Those are your three main test types. Oh, Allison wouldn't love me if I didn't talk about the race test. Don't use it. We hate the race test. It's just a game. It's an animation. It's actually kind of cool. I just don't find any practical use for it, so I like to make fun of it and get Allison to punch me in the face when she sees me. So that's why I'm razzing on the race test. So your main test types, here we go. We're going to roll on, VRS, and ramp. Those are going to be your main three ways to set up a dyno test. I'm not quite sure, haven't decided how I'm going to work this out. There's going to be weird cuts in this because I'm probably going to Rambletron, to quote Matt Happel. I guess we'll just we'll dive right in and start with a gear roll-on test. Under a gear roll-on test, you're going to select gear roll-on, and then you're going to go over. It's my kid. She's mad. All right, I have to back up now because I'm going to lose my train of thought. I said we'll start with a gear roll-on test. So I went, we'll start with a gear roll-on test. There's going to be a lot of cuts in this. starting with a gear roll-on test, moving over. It's really hard to get work done in your own house. Starting with a gear roll-on test. After you select a gear roll-on test, you're going to have some load options. Chassis dyno, guys, if you're not running a super high-power car, if you're running up to 450 horsepower, and especially if you're running NA vehicles, you probably have enough, and I'll say this, 24-inch chassis dyno, guys, so the big rollers. You have enough inertia that you're not going to really need any load, unless you're trying to light off a turbo. That's hard to light off, something like that. But like I said, NA cars, low horsepower cars, you can select none, and you will not be using the eddy brake at all. Now make sure the eddy brake is powered off. If you have a wall switch, or if you just have a plug, unplug it, because there will be a little bit of voltage leak over if you don't do that. So you can select none if you just want to do an inertia only dyno pull, like the old school drums in the ground that we see all the time. Next to that, also a little more useful on the roller dynos, on chassis dynos as opposed to the hubs, static load. If you're just adding a static amount of load, one of the cool things about the chassis dyno with an eddy brake is the ability to apply load. The other cool thing is, like, the inertia of the dyno actually kind of overcomes the eddy brake a little bit. You're able to kind of do a static load where over the course of the run you're just essentially making the roll feel a little heavier, but you're not putting a dead stop to the car. I mean, obviously, unless you really load the crap out of it. Heavy dynos can kind of overcome that eddy brake a little bit easier just with that extra inertia and stuff. And then we have an interpolate load. I skipped right over dynamic, and that was on purpose because I've never used it. On an interpolated load, if we have a car that doesn't come on very strong in the bottom, you can sort of interpolate your load. You can interpolate it over speed. You can interpolate it over RPM. If you know, like, oh, my turbo should light right about here, you can bring load in a little bit heavier. So let's say I don't want a lot of load on the car from the beginning of the run, so I've got 4 at 2750. I know my turbos should come on at like 4400, so maybe right here, I'm going to go ahead and delete all these if I can. No, I need a positive integer. And then I want to bring a little bit more load in, and let's just say that's basically enough load for the rest of the run. So I'm just going to 12 it out the end, out the back there. That can be good for lighting off turbos and stuff in a roll-on type test. You know, there's other tests and other ways to do it. You can do it over RPM, and it'll be a little bit pickup specific based on what your pickup is. You'll kind of have to think about it. If you know what your speed is, if you can look at drive shaft speed in a data log and say, well, normally lights there, you can just do it over speed. Hub dyno, guys, this is about the best thing you got going. Well, I will say you can use static load on blower cars, like on a Whipple car or something. Static actually comes in pretty good, and it doesn't take a ton, especially with a lot of these newer cars with the multi-gear transmissions, where you can get pretty good on the other side of 1-to-1. You won't need a ton of load. Or you can run them in a 1-to-1 and just run a little bit more load. But yeah, so static load is not something you would use all the time on a hub dyno. Somebody count how many times I say You'll have better luck with interpolated load on the hub dynos. You are going to want to sort of taper it in. Now I'm noticing how much I'm saying and it's bothering me. I hate talking into cameras. With an interpolated load run, you're going to be able to sort of bring it in soft if you need to, and get heavier on the car as you go in. Or things like hub dyno guys like to leave on the brake, or like to get a little bit of speed in the axle in first and then two-step it. Like, you can rip the brake plug out, two-step it, roll it in first, and then let it go and let it shift. You can come in really heavy in the bottom, really, really heavy, and then if you know what mile an hour you're going to shift at, you can lighten up a little bit for that bigger gear ratio. So you're not pounding on the car quite as hard. I should go over some practical applications of that, or maybe reach out to a few people that have helped recently with their dynos and just be like, hey, send me these runs so we can look at them. Maybe for another video, that would be kind of cool. The predefined power ranges are not my favorite. I think if you talk to anyone at Dynocom, they would tell you whatever the power range is, go to the next step up. So if I was running a 500 horsepower car, definitely don't go to the 2 or 450. Let's say don't go to the 250 to 499. Go to the 500. That's depending on what gear you're running the car in. That's still not a ton of load. Hub dyno, guys, it's kind of important. I'll preface this by saying most of the cars that go on a hub dyno, the 1-to-1's as good as it gets. You can't really get on the other side of a 1-to-1. Most of you guys are running 2 speeds, 3 speeds, 4 speeds. Some of the 4 speeds, anybody with multi-gear 6-speed automatic or 10-speed automatic, anything like that. If you want to go past 1-to-1, if your 1-to-1 is 7 and you want to go to 9, if the gear is strong enough to take it, go to 9. Like you're just giving the hub dyno more of a mechanical advantage. Your horsepower number is not going to change. You're giving the dyno a little bit more of an advantage by cutting down the torque that's coming through the axle. So don't be afraid of that. If you can get on the other side of the 1-to-1, it's actually a good thing for these cars. It's a good thing for these dynos, especially super high horsepower stuff. Loose converters, blown cars with loose converters and 2 speeds, good luck. Godspeed. I love you. It's interesting, especially if your converter's got like a 6800 stall. I love you and I care about you, and you're gonna have fun. You can do it. I've done it. About the best way launching a car, since I'm just rambling here and we haven't gone off this screen yet, I should probably just continue going. But like I said, it's quiet here. I'm gonna think of things and I'm gonna be able to talk about them. Guys with really loose converters, start the car in the gear before the run you want to start in and get some speed in the axle. If you have speed in the axle, if you have that converter already turned in pretty good, start your test and let it shift. When you let it shift and then you're in the gear you want to be in, you're going to get a lot better of a response from the car. If it's running boost, it's going to boost up and it's going to behave a lot more like you would expect it to, per se, as opposed to just like blowing right through the converter and nothing happening. It takes some practice and it takes some playing with. Unless your car's a one-hit wonder, like, don't be afraid to play with it. And, like, you know, as long as you're not beating up on the car, like, turn the boost down, for God's sakes. You can do it. I know you can. And practice and see how the car behaves before you just go ripping it and going, something's wrong. It's not loading up. You might be blowing through the converter. Having axle speed and letting it shift goes a long way to not doing that. So there's that. I'm going to set up a hypothetical run. Let's just say static 15%. I'm on a chassis dyno. I got a 24-inch roll. That's what I like. I think they're easy to use. I think they're easier to set up. They just don't caster out of the way, and they're not pretty, and they're not everybody's favorite internet buzzword right now, the hub dyno. So that's okay. Static 15% load. On the next screen, and this is every run you're going to do, it's going to ask you how you're getting your RPM source. Without RPM, you can't calculate, right? So you need an RPM source. You can do no pickup, and when you do no pickup, the dyno chart is going to show you the same horsepower number it would have shown you anyway. And it's going to show you the most astronomically large torque number you've ever seen in your life, because it's pulling torque straight off the roll. It's going to be showing you shaft torque, and it's going to be a ridiculous number. All that being said, you know, tons of diesel guys that run and just graph horsepower only, you can always click the right y-axis and just put nothing there, and you'll be good to go. You won't have anything to worry about. Ignition box. You can take like an MSD box and wire it into your I/O and actually pull your RPM out of the ignition box. That totally works. And actually, I'm not sure if you wire into I/O now or if you wire into the iBox. I think guys with an iBox 2 or an iBox, I think that's the way they do it now, and I would have to ask to be absolutely certain, because I don't use that. Do I use like MSD boxes? Sometimes. Do I wire them into the dyno? No, because I'm lazy, me personally. RPM output from a coil. Never use that one either. Skip right over that. Spark plug, COP, or injector. This is an inductive pickup. So Dynocom does sell an inductive pickup. Every dyno company sells an inductive pickup. in my experience in the past, they're all kind of noisy. They're not my favorite. When they work, they're awesome because you just stick it on there and you're good. When they don't work, it's the most annoying thing in the world. When they drop out in the middle of the run and stuff, and you got the little busted parts of your graph, or something does that, or something funky, it's not fun. That being said, I know Dynocom has a new one, and it's coming out with the new hardware with the Dynocom GS stuff, and it looks pretty badass, and it looks super promising, and it's super isolated, and it's super clean, and it's super happy, and I can't wait to try it. But in the meantime, I'm going to tell you my favorites are going to be optical, gear ratio, and snapshot. Optical is the little Monarch sensor that ships with your dyno that plugs into the RPM box. When you use an optical pickup, typically you would point it at the engine crankshaft. You have that little reflective tape. You just get like a little 1/8 quarter of an inch piece of it, stick it on your balancer, point the laser at it. You need to be, let's see, within about 30 degrees to 15 degrees in each direction, facing it to get it to actually reflect back and give you something meaningful. The one that ships with the Dynocom units is a LED light. Monarch also makes a laser light. It's a little bit more expensive. I think you can buy them from Grainger for about $300. You probably buy them from Dynocom for about the same price. If I can find a part number, I'll pop it up on the screen. But they do make one that's a laser, where if you're like me, my dyno's outside sometimes of day, the sun's kind of bright, it might be coming in just the right way to get under the awning and get under the hood of the car. Something like the laser, where it's actually brighter, works a little bit better in direct sunlight, so you, in the instance that you might actually have a problem dropping out, there's that. I don't use the little magnet base that a lot of people throw, that magnet base on a piece of plate and then they use that to point the optic at the crankshaft. I don't do that. I usually end up bending pieces of metal laying around the shop, drilling holes in them, welding them, clipping them on with needle nose, clamps. Something to attach the actual device to the car, because when the motor torques on the it's not going to, when the motor torques on the engine mounts, it's not going to torque a ton, and if you're attached to the car, you're going to stay on that balancer. If you're attached to the dyno or the floor of the shop, not only now is the motor mount moving, the front suspension of the car is moving too, so it actually moves more, and you might have to fight yourself. You might be dropping the signal that way. So I like getting it on the car, pointed at something. I'd rather be attached to the back behind the radiator somewhere, pointing in there, or coming off the block. That works better for me. Not saying you can't use the piece of plate on the floor. It's just like when it drops out, know why. It's because everything's moving. You don't have to get on the crankshaft while I'm thinking about this. You can see the user-defined optical pulse ratio. So the crankshaft is a 1.0, so it's going to be you don't have to get on the crankshaft. You can get on the camshaft. So if you just go over here, you see the crankshaft, the ratio is 1.0. Engine crankshaft, it's 0.5. I don't have to explain to you guys why, because you guys know how motors work. You can do a user-defined optical pulse ratio. User-defined, it's, let's say I can't get on the, let's say you got a dual cam motor and it's got a cover on the front of it, so I can't get on the cam, I can't get on the crankshaft for whatever reason, it's too tight, it's a 2J, so it's all the way up. It's a 2J in something it shouldn't be in, so it's all the way up. So I can't get on there, but I see a pulley. There's some kind of pulley up there. If you can measure the balancer and measure that pulley, you can make a ratio, and you can actually put your own defined ratio, and you just divide one by the other, and you can put your own defined ratio in there, and that will work. I'm going to go back and keep talking about these things. Gear ratio. If you know what gear you're running the car in, and you know the rear end that's in the car, you can use gear ratio. If I'm running a car with a, let's say this car is a 373 rear end, and I know that fourth gear in this car is the 1-to-1 ratio, and I'm going to run the car in fourth, then the 1-to-1, well, fourth gear's ratio is 1 times 373 is 373, so you can just manually enter the gear ratio. You can do that with fourth gear. If fifth gear is 0.83, you multiply 0.83 by 373, and that's going to be your gear ratio. Whatever gear you're running in times the rear end, you put that number in there, and the dyno will derive horsepower from that ratio. It knows that whatever the roll is turning, the RPM's ratio for the engine is the number that you enter. Snapshot does the exact same thing, except you're going, I have no idea what gear ratios are in this car. So when you do snapshot, you're just going to come in here and the snapshot trigger RPM is that's the RPM I'm going to start the run at. So as long as I'm not lying to the dyno and I'm trying to be consistent, snapshot works great too. I'm going to start my dyno pull at 2500 RPMs. So if I have 2500 in there as my snapshot trigger ratio, that's me telling the dyno, trust me, when I hit the go button, the tach is sitting at 2500. On gear ratio, I highly recommend clicking lock snapshot ratio for all runs. It's going to take the snapshot from the first run, whatever ratio the dyno derives from you saying I'm at 2500 RPM and it knows the RPM of the roll. That ratio, it's just going to apply that same ratio to every run after that. So after the first run, when you do your due diligence and you start the run at 2500 and you're actually at 2500, every preceding run is going to have the exact same ratio, so you can start at any RPM you want. As long as you stay in that same gear, you're good to go. And that's useful. I will say, if your snapshot is a little bit off, who cares? I'll show you in a run how to actually change the ratio in post. You can change it. You can slide the graph back and forth if your RPM's a little bit off. You can fine tune it. But as long as you lock the ratio, at least you know a gain is a gain, and my RPM is the same, no matter if it's off a little bit, for every single run after that. Final screen before you set up a run. On this screen, if you want to leave any notes, if you change parts on the car or anything like that, you can put your notes down in here in this little jobber. Use atmospheric sensor data. Always leave that checked. That uses your weather station just to correct for SAE. Run specifics down here. If you guys have one of the smaller chassis all-wheel drive dynos, or a 15,000 FX, a 15,000 FX, 5,000 FX, 6,000 FX, any of the linked all-wheel drive dynos, if you're running it in all-wheel drive, if you have the belt actually linked up, the coupler engaged, you want to make sure that's checked. You're just telling the dyno, account for the extra inertia of the front rollers. Now everything's linked up. If you're running it in two-wheel drive mode and you're unlinked, make sure that's unchecked. You're just telling the dyno, just worry about what's back here, don't worry about what's up there. Guys that don't have an all-wheel drive dyno, you don't have to care about that. Temporary hold current speed on run start. If you check that and you put in a hold time number that is greater than 0 right here, when you press the go button, the dyno is going to use a PID loop to attempt to hold you in a steady state for the amount of time you tell it. When people use this, I tell them hit the go button like you're going to start your run. You're going to hit go, and then for a whole second you're going to go hit go 1001. Now I'm wide open throttle. So you don't just jam it in the floor. The dyno's PID will you'll start rocking back and forth while it tries to catch up to you. So if you want it to hold you steady for 3 seconds, put 4 seconds in, because you're going to go button 1001, 2, 3, 4, and then the dyno's going to let you go and start the run. So just don't be super violent if you do use that. Guys with like 4 cylinders with a turbo, it's pretty good for lighting off turbo, stuff like that, or getting everything loaded up. It's good for stabilizing temperatures before you start your run. That being said, I don't use it all the time. I probably use it on 4 cylinders, and that's about it. Or things with heat soak issues, stuff like that. Don't use it a lot. But I have a 24-inch roller, and I kind of use it like a traditional 24-inch roller. Feed forward control, you don't have to worry about that in a gear roll-on type test. But we will talk about that when we talk about ramp tests. After that, you click finish. When I click finish here, it's going to bring up the gauge screen, and then I'm ready to go. Start my green button to start the run, green button to end the run. Don't think I've said that yet. I will say that when we actually do runs on the dyno. The red button does not stop the run unless you tell it to. You have to tell it to in the software. There is a Rambletron video where we talk about that. I like saying Rambletron. I like ripping off Matt Happel. I'm going to go back now. So that's a roll-on test, gear roll-on, GRO. Next test, virtual road simulation test. So when we set up this session, you saw me select all that Camaro stuff. All that comes from a drop-down menu. And that drop-down menu is where this data comes from. In the instance of this one, we have vehicle dynamic coefficients. I'm trying to think what year, sometime around 2007, 2008, everything started having the dynamic coefficients A, B, and C. So everything, I think it's 2008 and above, pretty much everything has that as their data for the EPA. If that's not filled out, if you have an older vehicle, it'll usually have the power at 50. Will be populated with a number that's not zeros, and you can use the power at 50. If you have the A, B, and C, I recommend using them to load the vehicle. It does a little bit better job. Otherwise, you can use the power at 50 if it has a number in it. If it doesn't, you can use vehicle parameters. There's a couple different ways to set this up, but literally, if you just run with the pickup truck and maybe throw a little bit more frontal area at it, like 30, it's going to be enough load. You're running these cars in 1-to-1. It's not going to be a ton of difference. If weight's going to be more of a factor out on the road and out there in the world, but like on the dyno, it's not going to be the worst thing ever. You can drop your weight down to whatever you know the car to be and just drop a 30 in here and use these pickup truck settings for everything else, and it'll be enough load that it's going to feel about right. Is it correct? No, it's not. If you have, and on even older vehicles where you don't have power 50 and you don't have A, B, and C, sometimes this is populated, so you could just roll with it. But if it's not, if it's natively set on that 2836008, you can use that and it'll be pretty close. It's not rocket surgery. So since we have an A, B, and C, we're going to use A, B, and C because that's the best one to use. Go to the next screen. Pretty much every run after this sets up the same way as the other ones do. I can say, hey, this one I'm going to use gear ratio, and it's, I mean, I'm actually pretty sure this Camaro was a 373. So I'm going to put 373 in there, and then from this screen, you don't get the option of a temporary hold with the VRS. It's just not in the cards. That doesn't work the way you think it would, nor is it necessary, because the dyno is going to be loading up with the eddy brake from jump, so you don't need it. You can use feed forward control on VRS. What feed forward's going to do, it's going to look at the first run and see how the PID loop ran, see how it loaded the car up, and it's going to give itself a bounds. It's going to, if you guys know how like feed forward boost control works, it's going to operate within a bounds that it knows works. So that all the preceding tests will be more similar. So feel free to use the feed forward control if you want to. Is it necessary? No. Is it helpful? Yes. And that's how a VRS test works. They're all pretty simple. And then we come down here to the ramp test. Ramp test looks a little bit different. Your test channel can be speed or it can be engine RPM. As it's set up natively right here, you see it has an acceleration rate. I want to accelerate 1,000 RPMs a second. You could put 800 RPMs a second in there. You could also set it up over speed and say, oh, I only want to go 12 miles per hour per second. So so that's velocity over seconds, RPM over seconds. That's just per second what you want it to do. Start ramp on run start. Yeah, you want that selected. Use the entered accel rate. If you do not click use entered accel rate, see here we have a start value. So saying I'm going to start the test at 50 miles an hour. I'm going to end the test at 120 miles an hour. And I want the test duration to be 8 seconds long. You could set it up that way too. I have a little bit better luck setting up accel rate on the smaller dynos the smaller hubs where they don't have a whole lot of eddy brake. You'll have a little bit better luck picking a steady accel rate and just giving it one thing to target and a little less to think about in the processor of the unit. So I would recommend on those just using, look at that, it automatically calculated what that would be, I think. But just something like in there that you want it to do. Next screen. Oh, I jumped 2 screens. It's going to ask you for your pickup type. Any of the tests that run a PID loop, so that would be the VRS test and the ramp test, I recommend using gear ratio and snapshot only, especially if your dyno is an older unit. These processors, I don't like to put too much on their plate, and having to also read an optical RPM or some external device while it's trying to run a PID loop is not going to be its favorite thing ever. So I just want to give the processor all the chance it can. So I'd rather just run gear ratio or snapshot as my source on a hub dyno, particularly because. So we're saying we do gear ratio. Everything looks the same after that on the tests. When you get this final screen, again, you can do feed forward control. Feed forward control works really good with the ramp test. I'm a fan. You can do a temporary hold at the beginning of the test, and I actually recommend doing a temporary hold because you're going to get the car loaded up and get some load into the dyno, and the dyno is actually going to be letting itself down rather than trying to come up to catch the car. And that's a good thing. So those are the main 3 tests that you're going to be working with. I'm going to come back here just to address one thing, and then I'll probably cut this video kind of short because I hear people stomping upstairs like they need my attention. I said that the gear roll-on test, even on the hub dynos, was my favorite test because of how stable it is, because I know it loads the exact same every single time. Here's the thing, I've never dynoed this car, whatever imaginary car we're talking about right now. I've never dynoed this car before. I don't know what it's going to do. I'd probably first to do a ramp test. Now, I preface this by saying a ramp test will never read the same power that a roll-on test. It just doesn't. Apples to apples, oranges to oranges. They don't compare. They're 2 different tests. There's no SAE standard for how to test a car on a chassis dyno. If there was, we'd only have 1 test. But I'll run the car in a ramp, and then on your graph, on your y-axes, on the left and right of the graph, you can actually select to see what the PAU did. You could say PAU1 and PAU2, or it'll be CMD PAU1, CMD PAU2, so commanded power absorption unit for each side of the dyno. So that's going to be what load did the dyno actually command? How did it run that? And you can go down the graph and see at this mile an hour I had this much load, at this mile an hour I had this much load. I liked the way that loaded up, or I think it should have loaded up a little bit heavier. Pick yourself 4 good points along that graph, and you can come back and you'll know how to set up an interpolated load. You'll say at this speed the dyno was at, let me take these predefined ranges off. The dyno started at 22. At the end of it, it was at like 36, so we're talking about 5500 series dyno with a 700 horsepower car. I like 25 right here. 35, excuse me. I'm gonna say 29 right there. So starting at 22, kind of coming in hard, and then just ramping it out the back. And I like the way the car did that, you know. And that's how I approach a car that I've never run before. I'll usually run them either in a, if it's a high horsepower car, skip VRS, go straight to a ramp test and see how the dyno loads it up, and it'll give you an idea of how you want to load it up. And then I usually come back and set up a roll-on test, so that as kind of as I'm keying into the car, as I'm actually making more power and turning stuff up. Me personally, if the car's at 700 horsepower and it takes it 7.5 seconds to complete the pull, then when it's at 1400, I would love for it to be taken 4.5 seconds, because I don't want to scatter shit all over the shop. And that's me personally, so I just know I'll have the same load on the car all the time. I reduce my variables, and then I have repeatability that's dead nuts every single time. So even if I don't make any changes, it's going to be within 1 horsepower every single time, 1 or 2 horsepower. That's my only thought there. I'll pack all my shit up out of my basement and take it to the dyno tomorrow, and we'll actually do some stuff on the dyno where it's going to make sense. And maybe I do have a Rambletron video also where I go through just randomly talking about all this stuff back here that you guys can play with. I just kind of bounce around the hardware and just blah, 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 and talk about stuff and tell you how to save your settings. You go in here, once you have the dyno set up the way you want it, make sure you save your settings. Yeah, just make sure you save your settings. Other little things before I close, under the load setting on the dyno, I can't say this enough. Guys, if you don't have your auto zero trigger force set to 0, set it to 0, and make sure where your auto 0 load cell before run is clicked. That's going to go a long way in helping you be repeatable. Sometimes the load cell can stray a few pounds, and I mean, a 5 horsepower gain or a 5-pound difference in the load cell, it's not going to be something super out of bounds, but it is going to be noticeable, especially if you didn't make any changes to the vehicle. When you have the auto 0 trigger force set to 0, every time you start the run, you want the car to be sitting still. You don't want to be rolling when you bring your gauges up to start a run, and it'll say auto 0. You just chill out, let it auto 0. It takes about a second and a half, and when the dialog box goes away, you're good to go. Drive the car up, start your run, finish your run. And every time you bring up those gauges, it's going to auto 0, so you just want to make sure the car's sitting still. So just while I'm thinking of that, make sure you guys set that to 0. And I should be able to show you guys all the other stuff at the dyno, so I'm going to wrap this up, and we should be good. That's it. Thank you guys. Beep, 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 beep.